Welcome to This Explainer. Okay, today we are rolling up our sleeves and diving into the practical side of AI system design. We're zeroing in on Chapter 13, Running the Code. Because let's be real, reading about AI architectures, that's great and all, but until you actually set up an offline companion repository and navigate that code base yourself, it's really just theory. I mean, you wouldn't trust a pilot who only ever read the flight manual, right? Same exact logic goes for building AI systems, so let's get our hands dirty. You see, staring at abstract boxes on a whiteboard is one thing, but executing a real modular AI engine, that's where the rubber actually meets the road. Reading a design and running a design are completely different beasts. It's super easy to say you know what a vector database is, but watching a system fail safely, seeing evaluation happen in real time, knowing exactly where to place your guardrails, that is what interviewers actually care about. They don't just want you to name the car's parts, they need to see if you can actually drive it. Here's our quick roadmap for today's tour under the hood. First, we'll talk about why you need to stop reading and start running. Then, we'll step inside the code repository itself, look at swapping your AI provider, explore co-learning with AI agents, and finally, wrap up with rebuilding for true mastery. All right, let's jump right into part one. Stop reading, start running. The core philosophy here is just delightfully simple. Every single case we look at ships with a small, runnable, offline by default companion repository. You literally just clone it and run it. And honestly, the best part, 0 API keys are required to get started. I mean, we've all been there, right? You run a test loop by accident and suddenly you're watching your credit card balance completely drain because of runaway token usage. It's the worst. But since this runs on a deterministic offline policy first, you can tinker, break things, and test out the logic without spending a single dime or hitting any network rate limits. Now, it's crucial to understand that these aren't those bloated, massive production repos that take you like an hour just to set up the environment and untangle the dependencies. Not at all. They are bite-sized, roughly 100-line examples designed strictly for your learning. Being completely offline and provider agnostic means they are safe for coding at a coffee shop when the Wi-Fi inevitably drops, or for plugging right into continuous integration testing. It lets you hold the entire shape of the system in your head without drowning in a sea of boilerplate code. Moving right along to Section 2, let's take a look inside the code repository. What is so amazing here is the absolute predictability. If you open any case folder, you're going to find the exact same 4 foundational files waiting for you. This lets you navigate the code in what we call spine order. So run.py is your entry point and self-test runner. Then you have lmm.py, which acts as your provider agnostic path to the model and holds that awesome offline policy we just talked about. Plus, you've got your standard requirements and README files. If you learn this basic layout once and navigate it in order, you basically own the foundation of any system design case. Now, alongside those core 4, you'll also find the domain modules. Think of this as the custom wrapping layer where the real system logic actually lives. For instance, a kb.py file for a customer support agent. This holds the knowledge store and the retriever, along with its absolutely crucial relevance floors. And let me tell you, that relevance floor is load-bearing. If a user's query matches absolutely nothing in the database, it retrieves an empty context. This purposefully triggers the agent to escalate the ticket, rather than confidently hallucinating total nonsense. That is exactly the kind of tight control you need. Notice how perfectly all of this maps to the 5-layer spine of system design. Layer 1, the model layer, maps strictly to llm.py. Meanwhile, Layer 2, the wrapping layer that contains your knowledge, tools, and memory, maps directly to modules like kb.py. By totally isolating the unpredictable AI brain from the strict, hard guardrails of your system, you're proving to an interviewer that you know how to build safe, scalable architecture. You aren't just crossing your fingers and hoping the LLM behaves, you are actively engineering the boundaries. Which brings us perfectly to Section 3, swapping your AI provider. Transitioning from your safe local testing up to a live cutting-edge API is literally a frictionless 3-step journey. Step 1. Validate the behavior locally using your offline policy. Step 2, install your provider's integration, whether that's OpenAI, Anthropic, Gemini, whatever you prefer. And step 3, just set an environment variable. Because the code relies on a completely provider-agnostic call, the rest of your system, your tools, your routing, your evaluation logic, it doesn't even know the brain just got swapped out. Seriously, when the model sits safely behind that interface, surviving a massive AI upgrade is literally as simple as changing one variable, like Support Agent Model to GPT-4o Mini or Gemini 2.0 Flash. And this is exactly how you handle that classic interview curveball about model upgrades. You just pin the behavior with your evals, keep that clean interface, and hot swap the engine whenever a better, cheaper, or faster one drops. No massive refactoring required whatsoever.
All right, let's shift gears to Section 4, Co-Learning with AI Agents. Why on earth would you read a static text file when you can have an AI tutor read it for you? Point a coding agent, like Claude Code, Codex, Cursor, you name it, directly at the folder. These agent harnesses can ingest the entire architecture in seconds. They understand the state machine primitives, and they can answer your hyper-specific questions right there in the moment. It is honestly the ultimate pair programming experience tailored specifically to your own personal blind spots. Try giving your agent this exact prompt. Seriously, try this. Say, walk me through the system a layer at a time. Then, help me change something so I can watch the design move. Boom! You instantly transform passive reading into a dynamic, interactive sandbox. Break a relevance floor on purpose and watch the agent start hallucinating. Add a new tool and trace exactly how the model learns to call it. This kind of hands-on, co-learning iteration cements that 5-layer spine in your brain way faster than any tutorial ever could.
And finally, Section 5, Rebuilding for True Mastery. I really want you to stop and think about this for a second. How do you prove you've actually mastered the architecture and aren't just reciting framework documentation from memory? It is so incredibly easy to fall into the trap of memorizing syntax for a specific library. But in a real interview, the framework is just an implementation detail. The interviewer wants to see the durable spine, the retrieval step, the bounded tool loop, the actual guardrails. They want to know unequivocally if you can build the engine yourself.
So here is my challenge to you. Hand that job to your coding agent and port the entire case into plain vanilla Python. Strip away whatever framework SDK you usually rely on and re-implement the architecture completely in your own stack. When you build the state machine and the tool loop entirely from scratch, I guarantee you will experience a massive aha moment. You'll see exactly how much heavy lifting the framework was doing under the hood, and you'll realize just how much of the system actually relies on your core design decisions rather than some magical library imports. The undeniable, rock-solid proof that you are ready for the interview is passing those self-tests in your very own stack. Remember those assertions in run.py we looked at earlier? Those are your benchmark. If your plain Python version successfully routes a query, hits the relevance floor, and correctly escalates to a human, exactly like the framework version did, then guess what? You don't just know the code. You completely own the architecture. So the only question left for us today is, are you ready to roll up your sleeves and actually run the code? AI system design just isn't a theoretical exercise anymore. It requires you to execute, trace, break, and rebuild. Go grab that companion repository, trigger those self-tests, and start mastering the layers. Because at the end of the day, the engineers who build the future won't be the ones who read the most design docs. They'll be the ones who aren't afraid to break the build.